Howdy folks, Virtual Schmied with you here today, talking about how to draw some of these Bohr diagrams. So, remember back to Bohr. He was one of our scientists that came up with a model of an atom. And he said that electrons exist in these fixed energy levels. So if we just have any random thing, any random element that is, we've got our nucleus in the middle, and then he said that electrons exist in these rings going outward. So this would be like the first ring. Label that ring number 1. The second ring, label that ring number 2. And then the third ring, so on and so forth. We will label that ring number 3. So on these rings, they can hold differing amounts of electrons. So on this first ring, you can only hold 2 electrons. So first level, 2 electrons. Second and third level can hold up to 8 electrons. So let's do an example for boron. I'm going to slide my way over here. So let's do an example for boron. I'm going to put my boron right in the middle. So there is my nucleus boron. And boron has 5 total electrons. We know that because it is the 5th element on the periodic table. Boron is number 5 right there. So it's the 5th element on the periodic table. It has 5 electrons to place. And we can just start putting them in shells. Here's our first shell. And our first shell can only hold 2 electrons. So there is 1 electron, 2 electron. The second shell can hold up to 8 electrons. 1 electron, 2 electron, 3 electron. So that is the Bohr diagram for boron. On the first level, we only have 2 electrons. On the second level, we have 1, 2, 3 electrons. Where we're kind of getting this from is from these electron configurations. So remember back to 1s2, 2s2, 2p1. That is the electron configuration for boron. And I'll write that here. That is for boron, the element. Yeah. Boron. There we go, eh? So that is the electron configuration for boron. So we can see that on the first energy level, on the first level, right there, we only have 2 electrons. There is no 2p, which is why the first energy level can only hold 2 electrons. Then we get on to the second level. 2s and 2p are both on the second level. So we have 2s2, 2p1. So that's 3 total electrons. 2 plus 1 is 3. And that's why we have 3 electrons here. 1, 2, 3. Let's do another example. Let's do aluminum this time, because you guys have to do that one as well. So I'm going to do aluminum here. Slide that out of the way. So we can have our aluminum right there in the middle, and that is just representing the nucleus for aluminum, so what we have in the middle. Aluminum is number 13 on the periodic table, which means that I have 13 electrons that I need to place on rings. So I can go through. Here is my first level, and I know on that first level I can only hold 2 electrons. 1, 2. I'm going to draw my second energy level. There's my second energy level. So I've placed 2 of my total electrons. I need to place some more though. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I only put 8 electrons on here. 1, 2, 3, 4, 5, 6, 7, 8 on that second level there. I'm going to keep going out. I need a third energy level because I have 13 total to place, and I've only placed 10. So now I have 3 more. 1, 2, 3, or 11, 12, and then 13. So this is the Bohr diagram for aluminum. If you guys need some extra help, as always, if you have questions, hit up Live Schmied.